going to start out here. We're going to talk about Boolean operators. These are, I guess, into technical, call them binary Boolean operators. They take two inputs and they return either true or false. Our first example here is the greater than operator, and I put a 2 on one side and a 4 on the other side as inputs. I shift and enter and it returns false for us. I now have the less than operator. Again, shift and enter, this returns true. This next one is the equality operator, which is represented by the double equal sign. It's asking a question, does 2 equal 4? And the answer is, of course, false. The final binary operator is the not equal operator. And I have 2 not equal 4. Well, of course, the answer is true. Okay, so I just want us to kind of get our feet wet in those, because we'll be running into them as we get into the meat of this, which will be defining functions. Before I define my functions, I'll reiterate the practice that I've been doing since the beginning. It's just good manners that you try to, if you're going to import functions from outside of the package, that you do all those at the top so that your reader will know where to find them. That it's bad form and it's sort of rude to put these later where people have to hunt for them. So I'm going to be using NumPy, but instead of importing NumPy as NP as I usually do, I'm just going to import some specific functions from it. First square root, then absolute value, then the mean, then the standard deviation, and then the random object. So I put from NumPy import then each of these objects. Okay. And I'm going to be using my stats, so I'm going to import scipy.stats as stats. I shift and I enter, and that's imported. And we have been defining functions all along using the lambda operator and using more formal definition. I'm going to define quite a few functions right in a row here to show you things that we can do and then how you can nest them. The first one I'm going to call the two-tail decision. And this I'm foreshadowing here because we'll have a lecture not too far ahead where we'll talk about what this means. But within it, it has 2 arguments. The first is test statistic, and the second is critical value. Now, the only line I have in this function is a comment line. You can tell it's a comment line because I have that hashtag there, that pound sign, and it's telling the reader that this answers the question, should I reject? Well, I have this return, which tells me this is what the function is going to give back. Well, within that, I have this binary Boolean operator with test statistic on one side and critical value on the other. If the test statistic is bigger than the critical value, it will return a true. Otherwise, it returns false. Let me get this into memory and go shift and enter, and it's now into memory. And I'm going to test this two-tailed decision, put in a 27 and a 3. This should return a true. And it does. I test it again. I put in a 2 and a 3. This should return a false. And it does. Okay, so it's always good to test your functions to see if they do actually do what you plan for them to do. This next function I'm defining, def two-tailed test stat, this is going to define the two-tailed test statistic. It has inputs mu0, x bar, standard deviation, and sample size. It has one line inside it. That one line inside of it is the calculating of the standard error of the mean. But because in its return line, it's going to do some arithmetic. It's going to use my standard error of the mean and use it to calculate a z-score. So I take x bar minus mu in parentheses divided by standard error. Okay, and then so that's the z-score. And then I take the absolute value of that, and then that'll be the value that I return. So I shift and I enter, and now that function's in memory. And I run some numbers through that to make sure the arithmetic doesn't give me any errors. I shift and I enter, and it does a calculation. If you want to see whether this actually does what it should, it would be a good exercise for you to work this out by hand. This next function is I'm defining two-tailed critical number, with the input being the significance. So what am I going to do? I'm going to return stats.norm.ppf 1 minus significance divided by 2. And quite frankly, I think that this, okay, is about the same length as this. So I'm not saving any space with this. And I know I'm not saving any space with it. But what I am doing, I am making it readable. I am telling the reader what this function does, what is the meaning of this formula, and when it comes together, when we know more about the process, that'll tell us where it goes. So I shift and I enter. And again, I look up my two-tailed critical number with a significance of 0.05. I know what the answer should be here. It should round off to 3 decimal places, 1.960. Let's see if that is actually the case. Shift and enter, and right. When I round this off to 3 decimal places, it will round off to 1.960. Now this final function I'm defining, the hypothesis test two-tailed, and this again answers the question, should I reject? Check is going to answer it either as a true or a false. I only have 3 inputs to it. My input is the sample. My sample will be an actual list of data. Okay. My mu naught, this comes from the setting up of my hypothesis test, as does the significance. Okay. So I have to know my mu naught and my significance before I come near this function. Okay, I calculate my x bar, which is the mean of the sample. I calculate my standard deviation, which is the mean of the sample. Then I use the len function to calculate the sample size. It takes the length of the list, which will be the sample size in this case. Now, for the next 2 lines, and we'll refer back to previous functions, things I've defined. These are things that had to have been defined before this will work. I'll have a number. The critical value is the two-tailed critical number with the significance. My test statistic will take in my mu naught, my x bar, my standard deviation, and my sample size, and we'll return this number called the test statistic. Then I'll put the test statistic and the critical value through my two-tailed decision function, and that will give me the answer. So here I want to test it, so I create my sample. My sample, I'm going to have random.uniform from 20 to 30, and I'm going to select 35 points from it. I'm going to have a hypothesis test two-tail of this sample with the mu naught value of 25, right? Because this is a uniform distribution from 20 to 30. Its average should be right in the middle, 25, and a significance level of 0.05. I shift and I enter, and my hypothesis test is false. I should not reject. And so I'm interested to know what is the mean of the sample, what is the standard deviation of the sample. Well, the actual mean is, hey, 24.96, so almost dead on accurate, 25, with a relatively small standard deviation. And when I run numbers through my test statistic, it'll give me 0.18 again. So the first person, you shouldn't necessarily be putting anything together yet on these. I just wanted you to, can be such an involved process. I wanted you to see it one time before you saw it again.